Now listen up, LunGang. I've always got your back. On to the more important stuff. We need to be focused on paper 3. I'm a man of my word, so like I said in my paper 2 stream, then I'll go through a couple of applied questions with you the night before your exam, live on stream, just like I did with Pure. Nice. But you guys have shown mad love. It's been crazy. So here's a new challenge for you. If you get this YouTube channel to 10K before the 19th, then I'll do a LunGang special of a 12-hour long stream covering a mad, enormous amount of papers so that we cover every single question needed to pattern your A star. So blow this up, share this with your friends. LunGang on top for real. So we have Rex is completing a quiz. For each question, the probability that Rex gets a question correct is 0.55. Each quiz has 20 questions. Find the probability that in any given quiz, Rex gets exactly 9 questions correct. Good. This is binomial distribution question. The first thing we should always be doing is defining our distribution. So we'll let X equal the number of questions Rex gets correct. Make sure you always say what it's out of 20 questions. We're then going to say X is binomially distributed 20 and 0.55. Now we can do part I. Probability that X is 9. At least 14. I'm just going to write down what that is. Probability that X is... Actually, no, let's not do that yet. All right, so on our calculator, we're going to go menu 7, binomial PD for this, variable 9, 20, 0.55. We have 0.1185. Now, what inequality am I putting for part 2? So greater than or equal to 14. And then how do we rewrite it? So the only numbers we don't want is anything up to 13, right? Now, guys, if you have the graphical calculator, you set your minimum to 14 and your upper to 20. Or for the ClassWiz lot, which is the calculator I have, we have to rewrite it. So I'm just going to go straight to the answer. So let's go menu 7 down, 1, variable. X is 13, and we still have the same numbers. Actually, to be fair, that's just 0.13, isn't it? 0.13. Cool. In June, Rex completes 15 quizzes to prepare for his test. He decided to use a normal distribution to estimate the probability that he will get at least 180 questions correct. Find the mean and variance of this normal distribution. What's our n's and what's our p's for this? What we're using for n and what we're using for p. Each quiz has 20 questions. He's doing 15 quizzes to prepare for a test. We're talking about number of questions being correct. So we're talking about the total number of questions he's going to complete, and the probability that each one is correct is 0.55. Now we can say mu is NP. And then the variance is NP times 1 minus P, which will be 0.45. 165 times 0.45. So like once you've established, you know, some sort of basis, the maths is not hard. Doing this bit is not hard. It's knowing, you know, at the beginning what's n and what's p and all this stuff. That's the stuff that trips up students. Students don't really find it hard to compute binomials. Estimate the probability that Rex will get at least 180 questions correct. I mean, continuity correction. So let's let y, okay, so our normal distribution will be 165 and 74.25. Now, at least 180 means it can equal 180. But guys, after a continuity correction, what is it going to be greater than or equal to? Good. You subtract 0.5, yeah? Subtract 0.5. 179.5. But yes, good. Then we round that. Menu 7, normal CD. The lower is 179.5. The upper, something big. Sigma, now be careful. It's not 74.25. It's the root of that. Root of 74.25. 165. So we have 0.0462. Okay. All right. It says Zara is investigating how the temperature affects the surface area cover of bacteria in a Petri dish. He collects data on 11 separate occasions at controlled temperatures. She records the temperature, x degrees, and the surface area, y centimeters squared, where y is rounded to the nearest whole number. The results are shown in the scatter diagram. Use the scatter diagram to find the median surface area. All you're doing is observing the scatter plot. So if there's 11 occasions, there's 11 points. The median, you do 11 plus 1 over 2. So you're looking for the sixth. So in terms of reading, we have that one, we don't want that. 1, 2, 3, they're in line, so 2 and 3 together. 4, 5, 6, we want that. We're going to read off the 28. So it'll be 28 centimeters squared. The range. All right, the range is nice and easy. We're just doing the highest minus the smallest, right? Now the smallest we can see is at 21. We're going to minus 21. And the highest points are at 34, which is 13, yeah. Centimeters squared. The temperature was raised each time Zara completed the test. She believes that as she raises the temperature, so does the surface area. She calculated the PMCC for her data at 0.9251. Use this calculated value to carry out a suitable hypothesis test to investigate her belief at the 1% level of significance. So what do we assume to be H0 here? And H1. P is 0, good. Our population constant is 0. H1, we're testing good for raising, yeah. As she raises the temperature, so does the surface area. So even though they haven't said positive correlation, that statement implies positive correlation. We're going to say P is bigger than 0. Now we find our critical region. I'm going to hide myself. So we're looking at 11 and 0.1. We're cross-referencing that. We have 0.6851. Good. So that's our critical value. Our critical region then is any R value bigger than that. Yeah, any R value bigger than that at the 1% significance level, we can conclude that there is positive correlation. So we got 0.9251. So we're going to say 0.9251 is greater than this. Therefore, we reject H0. Yeah, there's sufficient evidence to suggest that we can say as she raises the temperature, the surface area does too. I'm just going to say SA for surface area. Nice. These are always the easiest 3 marks in the statistics paper. And for sure, guys, they're going to put this in the statistics paper. All right, it says Zara is concerned that if she keeps increasing her temperature, the surface area might start going down. Comment on how this concern may affect Zara's conclusion to the test in part B. How this concern will affect the conclusion. So won't be strong enough correlation, won't be in the... Yeah, so exactly. If surface area starts going down, this will reduce PMCC, which might fall out of the critical region, and hence accepting H0 instead. And there we go. And then there won't be any correlation between the two. Oh, Venn diagrams. Love a Venn diagram question. The figure shows a Venn diagram with 2 events A and B and their associated probabilities. Explain whether or not events A and B are independent. So we're saying the probability
of A and B is the probability of A times the probability of B. So the probability of A and B is 5/12. Now the probability of A is a fifth plus 5/12 times probability of B, which would be a third plus 5/12. Okay, so let's see what they multiply to give. Okay, definitely not the same. Therefore, not independent. Cool. Find the probability of A given not B. So this one, we're going to rewrite the statement. I think we all know what the conditional probability statement is. We practiced it a lot. The given changes to an and, not B, over the probability of not B. 1/5. A and not B, I agree. Good. A. We want what's in A and not in B. Then what's the probability of not B? Again, that should be quite standard. Not B is anything on the outside of this, which is a fifth plus 1/20, isn't it? We have 1/5 over 1/5 plus 1/20 with 4/5 then. Fill in the tree diagram to the right by calculating the probabilities associated with each branch. Well, we know what the probability of A is. Probability of A is going to be a fifth plus 5/12. 37/60. Then not A will be 1 minus that. 23/60. Now guys, can you tell me what this branch would be? What's that the probability of? So for example, this is the probability of A. Who can tell me what that branch is? It's saying, look, given we have A, yeah, given A, yeah, saying the probability that given we've just done A, what's the probability that we get B? Yeah, what's the probability of getting B? That's what that branch is B given A. That's the kind of idea behind this question. Now we can use the diagram to just do this. So B given A is saying, given A, given we're restricting our probabilities to this, what's the probability of B? Well, the probability of B will be 5/12. Yeah, so it's 5/12 divided by the probability of A. Yeah, you can obviously do the formulas and all that stuff, but you can kind of think of the idea as well. 25/37. And then this one will then be 12/37. Let's do the bottom branch. So this one being given not A, what's the probability of not B? Not B and not A over the probability of not A. What's the numerator, guys? On the branch here, we know what not A is. So not B and not A is everything on the outside of those circles. And then we have not A, we already know is 23/60. 23/23. This will then be 20/23. Are we all happy with that? What would not A or not B be? Okay, so not A or not B. I'll show you with highlights. This is not A. This is not A. Everything on the outside of A. What is not B? Not B is the everything on the outside of B. Okay, that looks better. So if it's an and statement means you're looking for the crossover. The only time you see crossover is everything on the outside of the circles, which is why not B and not A is 1/20. It's the only bit outside. If it says or means you can have anything shaded. So not A or not B would be everything that's not 5/12 in the middle. Yeah. So basically you just do 1 minus 5/12. The answer would be 7/12. Yeah. So Emila and Temi are studying the pattern of rainfall where they live in Camborne. Emila decides to record whether or not it is raining at midday for the next 20 days. Say the name of this sampling method Emila is using. Okay, so you can say systematic or opportunity sampling. Yeah, at every day at midday consecutively, you're recording something. So I say opportunity sampling, but you can say systematic as well. Opportunity sampling. If I'm honest, when it comes to sampling techniques, it's something you should just look at before the exam. Yeah, obviously we practice it together, but really you should just read it before the exam because it's nothing too crazy. You just need to know which one's biased, which one's non-biased. Opportunity sampling is biased. Emila suggests that the binomial expansion with n equals 20 would be a good model for the number of days in a 20-day period when it is raining at midday. Explain why the binomial distribution may not be a good model in this situation. If it rains on one day, the chances that it will rain the next day is probably higher than if it wasn't. Yeah, and you know that's obvious. But you don't want to say that it's a fact. You want to say that rainfall on consecutive days may not be independent. That's all you need to say. But yeah, I think saying P may not be constant for each day is also fine. So if you want to say any of those two, go for it. I just think the independence logically, makes more sense to me. But yeah, rainfall on consecutive days, especially in the UK, may not be independent. Temi uses data from the large data set from Camborne in 2015. He randomly selects 40 days from the large data set for Camborne in 2015. And for each day records the daily total rainfall, X millimeters. Some of her 40 days have TR recorded. Using your knowledge of the large data set, state what TR means. Suggest what Temi should do with these entries to clean her data set, and explain what effect this action is likely to have on an estimate for the mean daily total rainfall. And the first thing we should say is that TR means trace. You could set a range, but we could just say trace just means less than 0.05 millimeters. Good, and make sure you include the units there. So trace means less than 0.05 millimeters of rainfall. 3, clean the data using 0. And good, it would decrease her mean, because if trace means anything between 0 and 0.05, if you just drop it all down to 0, it's going to slightly reduce your mean. Yeah. So this will reduce the mean rainfall. Good. There we go. Emila summarizes her data in the grouped frequency table shown below. Use information to estimate the mean. Okay, so what are we going to do with that one? For mean, we're just going to take the midpoints. So here we have 2, 5, adding them and dividing by 2, so 11. Yeah? We can do that together. Let's just say mu is, we'll do 0 times 21. 0.5 times 7. Let's not write the whole thing, plus dot dot dot. 11 times 4. All over the total data. Wasn't it 40 days? 40 days. 1.7375. Cool. You could round that if you want as well. I don't mind if you don't. Find SXX to 1 decimal place. You have to do the variance something. SXX over N is variance. Yes. So then we're going to do the variance times by n. We're just doing that minus 1.7375 squared. There we go. Okay, so therefore SXX, I'm going to round this, so let's times this by 40. Yeah, we're timesing that by n. 438.0, isn't it? Oh, 439. All right. Temi defines an outlier as a value which is more than 3 standard deviations from the mean. Say giving a reason whether or not their couple be, oh my days, could be any possible outliers for Temi's data. All right, well, we did have the variance. We need to square root that, right? The standard deviation will be the square root of 13.99375 minus that 1.7375 squared. The 3.3. If mu is that, it's going to be less than 0, right? So that's not going to be possible. Let's do mu plus this. I'm going to use 3.31 times by 3. Add that to 1.7375. And please do stats first. Because, what's it? It can get stressful. And you can see, even though I'm writing these questions, I can stress myself out. But anyway, is the answer yes or no? Could there be possible outliers? Saying yes. I agree. Because 11.6771 is somewhere in the middle, you know, of that last group. And with that 4 there could be some above that. Yeah. So we could say the boundary is somewhere in the middle of the last group. So yes, there could be. Nice. All right, next one says, Sam and Nick are both practicing their shot put before their school sports day. Sam has never thrown a shot put before. Initially, the distances thrown follow a normal distribution with mean 3.5 and standard deviation 1. In order to achieve a podium finish, he must throw at least 4.5 meters. Find the probability that Sam throws less than a podium finishing distance. All right, so we have a normal distribution. Let's let x equal shot put distances. X is normally distributed with a mean of 3.5, standard deviation 1, so we'll say 1 squared. We want the probability of less than a podium finish, which would be x is less than 4.5. All right, let's see what that probability is. Menu, 7, normal CD. The lower is some negative. Upper, 4.5. Sigma 1. And we have mu is 3.5. 0.8413. More than 0.2 meters of a podium finishing distance. What inequality are we going to do for that? Yeah, 4.7, good. The podium finish is at least 4.5. 0.2 meters, more than that. X is greater than 4.7. So here we just got to change our numbers around. We have 4.7. To be honest, I don't know why I don't just do 9s here. I have to keep changing it. We have 0.1151. After practicing for a few weeks, Sam is able to throw with a standard deviation of 0.6. He claims that his mean distance is now greater than 3.5. Sam's PE teacher asks him to throw the shot put 15 times and found the mean distance to be 3.7. test at the 5% significance level, whether or not there's evidence to support Sam's claim. Okay, so we have a new distribution because the standard deviation is changing, isn't it? So let's let y, or the new shot put distances, y is normally distributed. Now it's still the same as before, 3.5, but the standard deviation is now changed. Guys, what's our H0 and H1 going to be for this? For H0, yep, we're assuming mu is 3.5. And good Mythil, we're now testing because his claim is now greater than, right? Good, so greater than 3.5. Now, what else do I need to do? I have to divide the variance by n. Yeah? So we call that the sampling means. Or the sampling distribution. We can call it y bar. Is normally distributed 3.5. But we're doing 15 trials, so 0.6 squared over 15. Now we can draw a diagram. Now I do it by finding the critical region. But you guys, if you want, yeah, this is up to you. You can work out what the probability is of getting 3.7 or more. I prefer the critical region route. So you have 3.5 and sigma. And we want to find out what does this value be. Let's call it small y bar. Such that this is 0.05. And it also practices all our different skills with the normal distribution. So we would say the probability that capital Y bar, now remember, if we want to do the inverse normal to find what's on the x-axis, you need a cumulative statement, so less than Y bar. So if greater than, yeah, would be 5%, less than would be 0.95. So Y bar, we're just going to do inverse normal. The area is 0.95. Sigma, when you root the variance, you'd get 0.6 on the top and then root 15 on the bottom. You have 3.5. Okay, so 3.75. Our critical region is any y value bigger than that 3.75 ... Which 3.7 is not within the critical region. So 3.7 is actually less than 3.75. In terms of your diagram, 3.7 is probably over there. It's not in that critical region. We're actually going to accept H0. There is insufficient evidence to suggest the mean is now greater than 3.5 meters. Yeah? But yeah, the other way you could have done is you just find the probability of more than 3.7. You would have got a value bigger than 0.05, and then you conclude the same way. It says Nick's shot put distances can be modeled by this distribution. Given that the probability of D is less than 2.8 is 0.3, and that D is greater than 4.1 is that, find the value of mu and sigma, give your answer to 1 dp. Now, the first thing is that if we want to do the inverse normal, everything needs to be a less than statement. So D is less than 4.1 would be what probability? Or D is less than 4.1 be? Good, Dana, and we do simultaneous. Good, 1 minus 0.15, which is 0.85. Now we turn it into the cumulative normal distribution in terms of Z, and that special symbol is phi. So you do your value minus the mean divided by the standard deviation. And here phi of 4.1 minus the mean over the standard deviation, 0.85. So that indicates to us we need to do the inverse normal distribution. Yeah, we have to do inverse phi. And then we should store those values. So we'll go, oh, not that. Menu 7 inverse normal. the area is 0.3, but you now need to change sigma to be 1 and mu to be 0. So you get minus 0.5244. Now, in terms of mark schemes, guys, they usually just take 4 decimal places. But I'm going to store that as A. I want to keep my answers as accurate as possible. Then let's change it to 0.85. And again, if you want to take that to 4 decimal places, that's okay. I'm going to store that as B. So we would times by sigma on both sides. In the real exam, I'd probably write a new line for this. Then we add mu. So 2.8 is mu minus 0.5244 ... sigma. And here 4.1 is mu plus 1.0364 ... sigma. And then there's no way of them telling you that you're just going to use the calculator here. Yeah, you could easily just add them up and do whatever all in the calculator. So mu is 3.2 and sigma is 0.8. There you go. There's our answers. All right, now we're getting to the mechanics side. 2 athletes, A1 and A2, are running along a straight horizontal road and are modeled as particles. At T0, athlete A1 passes through the point O with speed 4. A1 is moving in a straight line with constant acceleration, 0.8 meters per second squared. At time T is 3, athlete A2 starts from rest at O, moving with constant acceleration, 1.8 meters per second squared. Along the same straight line and in the same direction as athlete A1. At time T equals capital T seconds, A2 overtakes A1 at the point X. Using the model, sketch on the same axes for the interval from T is 0 to T equals capital T seconds, a velocity time graph for both A1 and A2. All right, so the graph, guys, should be quite simple, right? We have velocity in meters per second. We have the time, seconds. Now, athlete A1 is starting at 4 meters per second here. And they are accelerating at 0.8 meters per second. And there's no other information there. And then A2 is 3 seconds later and accelerating at 1.8. At time T equals T seconds, where is capital T? Where would you put capital T? T is going to be somewhere on the right side of the two. Yeah? Yes, good. And they would have covered the same distances. Yeah, so for them to... Oh, wait, what does it say? Explain why the two graphs must cross before time. Oh, I've literally just explained it. I should have read my own question, but it doesn't really matter. So, before T is when... I don't need a comma there. Before T is when A2 is catching up to A1. We know this because at some point before T, they must be traveling at the same speed. You can then even say A1 started off faster than A2. And A1 started off faster . than A2. I'm always like quite thorough about these answers. I just say as much as I can, even though it's 1 mark, just say a lot. Find the time when A1 and A2 are moving at the same speed. Okay. So for that, we're going to have to write down the equations of motion for both. Who can tell me what the equation of motion for A1 is? Now for A1, we know what U is. It's 4. The acceleration for A1 was 0.8 t. Now be very careful about A2. What is the equation of motion for A2? If you think about it, for the second athlete, when they have been running for 3 seconds, athlete 1 has been running for 6 seconds. So we need to think about this generally. Meaning, for every time that athlete 2 has been running, athlete 1 has already been running for 3 seconds more. So the way it looks is that for A2, yes, U is 0 and the acceleration is 1.8. But you need to write down the time relative to A1's time. If A1 has been running for 3 seconds, A2 has been running for 0 seconds, which means it's whatever A1's time is minus 3. If A1 has been running for 6 seconds, A2 has been running for 3 seconds. If A1 has been running for 10 seconds, A2 has been running for 7 seconds, because they started 3 seconds later. And now we can equate them. Let's expand it. Isn't that 5.4? Add that over 9.4 is just t, isn't it? That's it. That's how long it takes. Find the distance OX to the nearest meter. X is the distance traveled by both where they overtake. Yeah. And as you guys said, it's to do with the areas, isn't it? Athlete 2, the area is this. Now, the only thing about what we need is we need the height. Can you guys tell me what the height of that triangle is? I'm going to write it here. For A2, it's a half times the base length. Now, the base length is t minus 3, isn't it? Can you guys tell me what the height of that triangle would be? All you're doing is subbing t in with capital T. Yeah, 1.8 capital T minus 3, which we might want to simplify. 1.8 times a half is 0.9. Are we all happy with this A2, yeah? Now for A1, we have the trapezium. I'm going to do it above that A2. So the area for A1 is this, the trapezium, isn't it? Okay, so it's a half H. Now identify the parallel sides is 4 and whatever this height is. Yeah, it is 4 plus 0.8 capital T. Good, because we know the equation of this line was 4 plus 0.8 T, and we're just replacing it with capital T. All right, and then we need to equate them, find out what capital T is, and then sub it into one of them to find the distance traveled. Yeah, we have a half T 8 plus 0.8. Okay, so let's expand and solve. So we have 4t plus 0.4 t squared is, let's expand A2 at the same time, so it'll be t squared times 0.9. T times minus 3 is minus 3t, double that is minus 6t, then times that by 0.9. Minus 6 times 0.9. Minus 5.4. t. Then we have plus 9 times 0.9, which is 8.1. Yep. Move everything over here. So you guys have more space than me, so do as much working as you like here. Now, guys, you have to do the quadratic formula in your working. Remember, in the exam, do the quadratic formula. I'm not going to show you that because you know how to do that. 0.5 minus 9.4 and 8.1. 17.89. Or, okay, now why are we getting two answers? T is 0.905 dot dot dot. What's going on there? Which one is it? It has to be bigger than 3, isn't it? At 0.9, athlete 2 hasn't even moved yet. So we're going to say not that. T has to be greater than 3, isn't it? Technically, it has to be more than 9.4. So from there, we're going to work out our area. Which means I would go back to this answer, store the value. This store is A. And let's type into one of those equations. I think the 0.91 is the nice one. 0.9. What I've stored is A minus 3 squared. There's 200 meters. There we go. A particle P of mass 0.25 kg moves on a smooth horizontal plane containing the origin O. At time t equals 0, the particle is at the point O, moving with velocity 2 minus 2. At time t seconds, the resultant horizontal force acting on P is that. Find the velocity of P at t equals 3. Use F equals ma. And also I've realized I haven't put parts here. So the force, we should always do this on column, and then we integrate good Dan to find V. So we have 2t minus 1 minus 5 is the mass, which is 0.25, which is a quarter A. So A, we're going to times it by 4. 8t minus 4 minus 20. So it's not constant acceleration, so you can't use Suvat equations. So V is going to be the integral of 8t minus 4 dt and the integral minus 20 dt. We have 4t squared minus 4t. Don't forget your constants. Now we practice this loads, but we know the initial velocity. So when t is 0, you have 2 minus 2. That just means c is 2 and d is minus 2. And this only works because we're dealing with polynomials. If we were dealing with sine and cos and all these other functions, it doesn't work. Because when you sub in t as 0, all those t's just disappear. Our final answer is the velocity is 4t squared minus 4t plus 2 minus 20t minus 2. Then v3, we sub in 3 there. Just going to do 3 store A. 4a squared minus 4a plus 2. 26 minus 20a minus 2 minus 62. So you can convert that back to I if you want I and j. Find the distance of P from O at t is 3. I think you guys know what we're going to have to do there. We're going to have to integrate again, yeah, to get the displacement. Distance of P from O is displacement. Yeah, you're doing it from your initial position. We're going to integrate 4t squared minus 4t plus 2 dt. Integrate minus 20t minus 2 dt. Four thirds t cubed minus 2t squared plus 2t. Now again, I'm not going to write it, but the constants will be 0 because it says at t is 0, we're at the origin. So when you sub in 0, everything disappears and your constants just have to then be 0. So remember, it doesn't work though with trig, because when you sub in 0 into cos, for example, you get 1. Minus 2t. And then from there, you're just going to sub in 3. Okay, I still have it stored. 4/3 a cubed minus 2a squared 2a. 24 minus 10a squared minus 2a. Okay, is this my final answer? You're happy with this? We have to find the magnitude because we're talking about distance, right? Cool. So I'm just going to say modulus x3, 24 squared. I have this as my answer button. 24 squared, answer squared, root. 24 root 17. There we go. So it says a fixed rough plane is inclined alpha. Tan alpha is 5/12. So let's get some marks here. We do alpha. Tan is opposite 5, adjacent 12. It's the 5, 12, 13 Pythagorean triangle. We have a pulley at the top of the plane. A and B, mass 2m and 3m. So without even reading on, 2mg, R, 3mg, and then we have tensions pointing away. Now, do you ever get marks for annotating that? Yeah, they'll mark your diagram basically. Yeah. So they will mark your diagram. They want to see evidence of the resolving on your diagram. Yeah. Now we have to just see, is it going up or down? A moves up the plane. Okay, so that means friction is going to point down. Say mu r. It's the acceleration that way and acceleration this way. I think that's it, right? So the next thing we have to do is resolve this. That's your alpha. This is 2mg cos alpha. I've done so much practice of this stuff with you guys. Sine alpha, and we can get rid of that. Find in terms of mg the magnitude of the normal reaction that the plane exerts on A. Okay, well that's to do with this r equals 2mg cos alpha. And cos alpha, when you read the triangle, is 12/13. So we have 24/13 mg. There's your answer. As A moves up the plane, the tension is 9mg/5. Coefficient of friction is mu. Using the model, write down an equation of motion for B, and hence find in terms of G the magnitude of the acceleration of B. To be very clear, equation of motion just means write F equals ma for B. So if we look at B, it's going downwards, so the positive force is 3mg, minus any negative forces opposing that is T, which we know is 9mg/5 now, equals the mass, which is 3m, times A. Notice m's cancel everywhere. So we're going to do in our calculator 3 minus 9/5. Then we're going to divide by the coefficient of A, which is 3. So 2/5. G. Find the value of mu. Okay, so we just need to do the exact same thing, but for A, isn't it? So positive force is T, which is 9mg/5. Minus mu r. R we worked out to be 24/13 mg. We are also subtracting done that. Minus 2 mg sine alpha. Sine alpha is 5 over 13 equals the mass of A, which is 2m, times the acceleration, or which is 2/5 g. Now, just to predict this, if we work out mu to be negative, which I don't think is going to happen, but if it does happen, actually it might happen. It just means my 3 mg wasn't big enough. I would have to change it to like 5 mg or something. Let's just cancel all the mg's. I hope mu doesn't become negative. And we're going to move that over to that side. And this can come here. So we'll have 9/5. Then we'll have minus that 2 times 5 over 13. Minus the 2 times over 5. And that equals 24 over 13 mu. All right, let's see what happens. 9 over 5 minus 2 times 5 over 13 minus 2 times 2/5. It's going to be negative. Oh, not negative. That's a relief. Sometimes I should have more trust in myself. The 13s go. 3 over 24. Mu is 1 over 8. Okay, there we go. That's a really nice question. 5 marks for that, for just reading the diagram. In reality, the rope would not be light. State how this would affect the tension in the rope. Wouldn't be constant throughout. Yeah, so there wouldn't be constant throughout. Yeah, don't get technical with this. Simple answer they're looking for is it won't be constant throughout. The point A is 2.5 meters above horizontal ground. A stone is projected with velocity 2ki plus kj, where k is a positive constant, from the point A. The stone first hits the ground t seconds later at point B. The point B is at a horizontal distance of 100 meters from A. In an initial model, the stone is modeled as a particle. Moving under gravity, air resistance is ignored, and the stone has an initial speed of v. Show that kt is 50. Vertical, horizontal. And you fill out as much as you can. Remember, for the horizontal, there's no acceleration, so you just say distance is speed times time. Now, I annotate the diagram, but in vector form, it's always great because we know the horizontal and we know the vertical. The horizontal is 2k, and the vertical is just k. So for the vertical, when we hit B, we know we're below our point of projection, so it'll be minus 12.5. U is up, that's k. V, we don't know V when we hit B. A is negative. Yeah, because we're projecting upwards. And we don't know what the time is when it hits there. Now for the horizontal distance is 100. The horizontal speed is 2k. And we have t. And it's from the horizontal you realize how we get kt as 50 by just dividing both sides by 2. Also, we've done all the hard work for part B. Find the value of v. So for that, we're going to write down our equation of motion for the vertical. Because in order for us to find v, it says the initial speed, v, we need to do Pythagoras to our component. So basically, we need to find k. Yeah, so in order to find v, we need to find k. We have one equation in terms of k and t. We need to find another one. As usual, SUAT. It's always the same stuff with these. S equals ut plus half at squared. So minus 12.5 is u, which is k, times capital T. A half of A, if A is minus 9.8, we have minus 4.9 T squared. Now, can you guys see how we could do this really easily? Should we just sub in 50? So we don't really need to do simultaneous equations. And we can go ahead and just work out what T is, which we can then go ahead and work out what K is. So if we rearrange that, it will be 4.9. We'll do 50 plus 4.5. And we're going to divide that by 4.9. 6, 2, 5, 9. It's the root of this. That's even nicer numbers. So 50 divided by that. 14. Nice. So here K is 14, 2K is 28. So V is a root 14 squared plus 28 squared. And you can approximate that if you want. So because we use gravity, right? So if you want to approximate that, we could say 31 meters per second to 2SF. It would accept both answers here in this situation. State two improvements to the model other than air resistance that would make it more realistic. What two things could we say? Good, include rotational forces. I like that one. That's my favorite one. The best thing is to say is consider the dimensions of the particle. Yeah? It says stone instead of particle. All right, nice. It says a non-uniform rod, AB, is held in equilibrium in a horizontal position by two light inextensible strings. The first string is held attached at A and to C. Second is attached at B and then to D. All points lie in the same vertical plane. Given that the rod AB has weight W and length D, the center of mass of the rod is a distance 2/5 D from A. Okay, so the first thing I was thinking about is that it says non-uniform, which means the center of mass is not in the middle. But then I was thinking, okay, where do I put it? They're now telling us 2/5 D from A. So it's closer to A than it is to B. So W, and we'll say 2/5 D. The string AC makes an angle alpha. Tan alpha is 24/7. Got a triangle. Opposite 24. Adjacent 7. This is the 7, 24, 25 triangle. We have beta. Show the tension the string AC is 5/8W. How would you guys label the tensions? Is it T and T? Me personally, I would say something that like maybe TC and TD. Just because they're pointing towards C and D. It doesn't really matter. But how are we going to do part A? What would you guys do for part A? Guys, we want to show that the tension AC is 5/8W, so we don't take moments from A or C, because if you take moments from A or C, TC disappears. It's acting through the moment. We want to take moments about B. We want to get rid of TD. We want to get rid of that one. Yeah? Exactly. We're going to take moments about B. One of them is easy. W times that distance. Well, remember, the whole distance of the rod is D, right? So we're going to do 3/5 W. So 3/5 D times W equals. Now, this is where students make so many mistakes. I'm going to clear the diagram just so you can see it. If you want, draw a new diagram. You do not, or you should not, resolve this tension. The definition of a moment is you take the force and you times it by the perpendicular distance. And when we did moments, we practiced this a lot. what do you have to do to the line TC to see its perpendicular distance from B? Yeah, we extend the line. So you just extend the line. Forces are just vectors. They're infinitely long. It's just in this diagram, I've just put it between A and C. But in terms of the force, it's an infinite distance. There is no distance attached to it. Now we can see the perpendicular distance. Yeah, this is the distance that we're interested in. Let me call it X rather than D. Because what we know is that this is D and this is X. And vertically opposite angles are the same. So guys, what is X here? It's sine, it's the opposite. And we have the hypotenuse. So you're basically resolving the hypotenuse in X. So it's D sine alpha. Yeah. You can see D cancels on both sides. We have 3/5 W is TC times sine alpha. Then sine is opposite over over hypotenuse, 24/5. And then I'm hoping that gives you 5/8. It does, because 5 cancels that 5 times. That cancels that 8 times. So yeah, TC is 5/8 W. Nice. Part B. Show that TB sine beta is 3/5 W. If the tension in the string... Oh, I've decided to call it TB instead of TD. Let's resolve them. So we have TB cos beta. Actually, no, maybe it is the up and down because that's what sine is. TB sine beta. And then here you have TC cos alpha and TC sine alpha. So if they want TB sine beta, we're going to do up, down, left, right. Yeah, you're right. We're going to say TC sine alpha for the up plus TB sine beta equals... So when you rearrange here, you'll get TB sine beta is W minus TC sine alpha. Now TC we worked out is 5/8 W. Sine alpha was 24/25. It should be 2/5, not 3/5. Okay. Find TB in terms of W. Okay, what's left is to just do left, right. Yeah, what's the left and the right? So by looking left and right, we see TB cos beta is TC cos alpha. So TB cos beta is TC, which was 5/8 W, times cos alpha, which is 7/25. Which the 5 cancels that 5 times is 7/40 W. So if I write it underneath, we have TB cos beta is 7/40 W. Do you know how, from this, we can very simply work out what TB is? You do Pythagoras. TB sine beta is 2/5 W. That's this length here of this triangle. And then this is the adjacent side. We just want the hypotenuse of that. So you don't need to know what beta is. You just need to do Pythagoras. Now for Pythagoras, you see they both have W in them. When you square them and root them, it's just going to be W. You just need to do Pythagoras to the numbers, the 2/5 and the 7/40, and just put W there. Everything is squared. Cool. But if you did find beta, it would have given you the same thing. That was a nice question.